I'll give you another minute or two. Not so up, though. Let's get those up and over, please. And have out on your desk your note packets from the other day. We should have been done with, I think, the first 2 days. Let's go over, please, to the middle of page 6 from the other day. Last time we had class, we dealt with some of the, we dealt with the sum and difference of perfect squares and factor by grouping. You need to make sure that you're going through and doing enough, so when you come in, if I don't give you a ton of homework or something specific, that you're able to go through and bang the problems out that you're going to be facing. Now, when we do these out, take a look at example 3. We're working now with the sum and difference of perfect cubes. The numbers that you need to know for perfect cubes are different than the numbers you need to know for perfect squares. The numbers that you need to know for perfect cubes, 1 is a perfect cube. We count that. It's a perfect square. It's a perfect everything. So we're not going to list that out. Your perfect cube numbers are 2 cubed, which is going to be 8. Then the next one is 3 cubed, which isn't 9, it's 27, because it's 3 times 3 times 3. 4 cubed is going to be 64, etc. Those ones that we listed out down in the bottom right with the blinking lights next to them, those are the ones you need to make sure you have down on your paper. The other thing is you need to know what the factorization pattern is for it, which means there's 2 formulas essentially that you're going to have to memorize. The formula itself is, I guess, more burdensome and complicated than actually doing it out. You need to be able to recognize right away when you have a binomial that's going to be a sum of perfect cubes or a difference of perfect cubes. When you factor it down into its prime component parts, you're going to have a binomial factor, which means a grouping of 2 terms, and a trinomial factor, which is a grouping of 3 terms. When we do this out, you take the left, and we talk about left and right, we'll see what we mean in a second, but the left minus the right makes up the binomial. The left squared plus the left right plus the right squared makes up the trinomial. So, what you need to go through and have down is this formula. Recognize that your pattern going across is going to be minus plus plus. That's the big thing. And it goes, the binomial is left right. The trinomial is left squared, left right, right squared. Now we're going to go over what left and right mean in just a second. Take a look at this first example A. The first thing I need to do is recognize it's a binomial. Is there a GCF? Yes or no? Nothing goes into both of those. How about is that a difference of perfect squares then, since there's only 2 terms? No, because m cubed isn't a perfect square and 8 isn't a perfect square. Are these perfect cubes? And the answer would be yeah. What times itself 3 times gives me m cubed? M. What times itself 3 times gives me an 8? And that's a 2. So I always ask that you list them out, at least in the beginning, list them out above the terms, because when we're talking about left and right, this right here is the left, and this is the right. Now, I'm going to show you one, and I don't want you to write this step down, because I want us to talk our way through it the first time, because I'm going to literally walk it through you like you're a baby. And then afterwards, we're going to simplify it down and express it how you give it as a final answer. The first thing I'd have you list out is, when you do a question like this, you need to make a space for the binomial factor and a space for the trinomial factor. So you list out a small parentheses and then a bigger one. And then the next thing is you need to remember your signs. If it's a difference, it goes minus, plus, plus. So I fill that in. When I'm constructing out the binomial factor, and again, you won't write this out, I'll tell you when you're just going to start writing it. I'm going to list out the binomial factor as the left minus the right. So in this case, my left is n, my right is 2. So left minus right would be an n minus 2. And then the next thing, hang on, don't write it down because we'll tell you when to pick up the pen. Then the next thing I'm going to do is construct a trinomial. And the trinomial we said is going to be left squared, left times right, and then right squared. So if I'm doing this out, if I take the left and square it, that would be m squared. And then the next thing I need to list out, there should already be a plus there, my middle term comes from the left times the right, or m times 2. And then the right squared would be 2 squared, and you'd have a plus there. Now, I wouldn't want you to show it out with that much detail. I showed it out this first time so you get the gist of what we're doing. This we can condense down, especially as enriched and honor students. My binomial would say what it is, and you can pick your pencils up now. This would factor down, simplify down to a binomial factor of m minus 2. Hands up, please, if you can tell me what the trinomial would be if you did the math or simplified down that expression. We got one person, maybe, two, maybe. That can tell me what our trinomial factor would be. Go ahead.
M squared plus 2m plus 4.
Terrific. Terrific. You've got to know them. You've got to do enough of them so they're automatic. And this will be a change for some of you. I'm not going to sit here and make you do busy work all the time. You've got to know and be able to do these things and do them quickly. Recognize the pattern right away. If you don't recognize the pattern and aren't able to do something like this in, let's say, 30 seconds, then you don't know it as well as you need to, I guess. Okay? And that means you just got to put more reps in. Some of you get it right away, and that's terrific too. Take a look at what we have for B. I want you to list out on your own the cube root of the left, and then the cube root. By the way, first thing, and I get late, I become a little bit of a lazy Larry. I'm not going to tell you the things that we do all the time. Is there a GCF of this? No. Is this the difference of perfect squares? No. That's the checklist you're running through in your head. This is a difference of perfect cubes, though. List out the cube root of the left and the cube root of the right first. Just a little chicken scratch right above it so we can see what it is. Have a 3x here. Cube root of the right is going to be a 2y. Then I'm going to go down to list this out. There's a binomial factor and a trinomial. So I'm going to make a space for a binomial and then a space for a trinomial. And I'm going to fill in my signs also. Hands up, please, when you can tell me what the binomial factor for this is going to be. We've got one person. We'll wait for 6. We've got 2. Thank you. What would my binomial factor look like? Look at the pattern. But you should fill those signs in automatically. When you see it's minus, it goes minus plus plus going across. What would just the binomial factor be? Seriously, we've got 3 people. 4. What do you want to say?
3x minus 2y.
There you go. That's the binomial factor. Now, I want you to give the right trinomial a try. Most of you are going to make a very casual mistake on this. You'll make the mistake once, you'll never make it again. But go through right now and tell me what the trinomial would be, which is left squared, left times right, right squared. Hands up, please, when you can tell me what that trinomial, what you think that trinomial would be. We'll wait for 5. I've got 1 so far. Thank you. Just 1? Really? Oh. Now, we'll discover this. While you were taking your assessment, I tried to go through when you gave me your names yesterday. You all have individually a card. Will caution you this. Not you all, but there were some seniors that I had last year that thought, you know how you never get called on? And I'm not looking. Guess what they did? What do you think they did to their cards? Took it out. A funny thing happens, though, when cards get removed from the deck, they're sort of like bunnies. So instead of having 1, I checked, and when they took theirs out, I found it, so I had to make a new one. It went from having 1 card to 2. Isn't that strange? And then they thought they could take one of those out. And they're like, well, you know, it's back to 1. So then they went from 1 to 2, and then the next time, guess how many they had? No, you're kidding? That would be if I was nervous. How many do they have? 4. See, that's an exponential progression. If they had done it again, I might have to eventually go and get their own deck. But and I'm going to apologize. I know roughly the A's are here and the Z's are back there, and it snakes around. So, Amanda, I'm guessing the groan is you. Congratulations, you are the first person ever picked in class. Have you won anything before ever in your life? You have? Is this more terrible than what you want? Okay, good. What are you going to say that your trinomial is going to be? Take the left and square it, so what would you have? And then what's the middle term going to be when you take left times right? Terrific, and then what do you have at the end? Now, you made the mistake. It's okay though, because your middle term is perfect and you made the common mistake that ever. It is not 3x squared minus 6xy, or sorry, plus 6xy, plus 2y squared. Who can tell me what the one error is that was made there? And you made the same mistake twice, so it's really just one mistake. Who can tighten that up, or who thinks that they got a little bit different? Go ahead.
3x squared plus 3x 2y.
No? Who can tell me why it's not 3x squared, why it would be 9x squared? Yeah. Don't forget about squaring the 3. And then at the end, you're going to have to do the same thing. If you're squaring something and it's a single term, you have to square all of those component pieces of it. Questions on that one? You won't make the same mistake a second time. Once you get it for the first time, you'll be great. All right, let's take a look now. We're going to do the sum of cubes. So there's one more pattern to recognize, but it's really not that different. Only one thing changes when I go from this difference of cubes to the sum of cubes. Hands up, please, if you can tell me. The only thing really that's changing as I go from the first formula to the second one. You need to get your pencil on the paper. Make sure you get that down. Go ahead. Yeah, so just remember the order of the signs. That's the only thing that's changing. That's why, again, this process is kind of easy. Your signs to remember are plus, minus, plus. There's still a binomial. It goes left, right, left squared, left, right squared. Now, with that in mind, I look at A for 4A. Is there a GCF? No. Is it a difference of perfect squares? No. Is it a difference of perfect cubes? No. Difference means what operation? Subtraction. This is not a difference of perfect cubes. It's a sum of perfect cubes. So looking at this, I'm going to have a binomial factor and a trinomial factor. Let's have you all do this first one out on your own. Alexis, is that you? Is that right? What's your binomial factor going to be?
R plus 2.
So far, so good. What do you get for the trinomial now?
R squared plus R times 3.
Which would be 3R. And then what do you have at the end?
Times 9 squared.
No. 3 squared, which would just be just 9. You had one thing wrong, though, there. Can you read me what that trinomial was again to make sure I heard it right? The R squared, right?
R squared plus 3R times 9, or plus 9.
Plus 9. There's one mistake in there. Is anybody here? Minus. Because remember, your signs going across are plus, minus, plus. This was right. Everything was correct. It was just that one little sign there. And the signs in the beginning are where you're going to sum. Now, take a look at question B. When you go through and do out question B, again, if there's no GCF, it's not a difference of perfect squares, it's not a difference of perfect cubes, it's a sum of perfect cubes. This one, I take its cube root would be 3z, and over here, this would be a 5. So go through right now, construct your binomial and your trinomial. Remember the mistake, the cache error that you made when we did out question 3b? Just make sure you avoid it in the future. Because like I said, once you make that mistake the first time, very seldom do you make it a second time. All right, so Taylor P., what did you get as your binomial factor? There you go. And see, Will C., what did you get when you did your trinomial?
I got 9z squared minus 15z plus 25.
Perfect. Perfect. Questions on that? They get harder. Let's go over. I'm going to tell you this. E is very much a push. I would doubt that you saw E. You're going to see E on a test. Or sorry, you would see E on a Regents exam. You could see something like C though. Before we go on to what C is, there's no GCF. It's not a difference of squares. It's not a sum of cubes. It's not a difference of cubes. This is a sum of cubes. Hands up, please, if you can tell me what the cube root of the left is going to be. We'll wait for 5 of you. We got 1, 2, 3. Go ahead. So I list out the 5t. Hands up, please, when you can tell me what the cube root of the right is going to be, or what times itself 3 times is going to give me what's on the right. We got 1, 2, 3 of you. 4, 5. What do you want to say? Close. There's more there. Now, this is where we get into the awkward part, because we're going to touch on some exponent rules. You're asking what times itself 3 times gives you s to the 6th power. It's going to be an s, but s to what power? Now, your guess was which one? Sorry.
To the what?
Third. What do we do to the exponents? What do we do to those powers if we're adding? Or what do we do to those powers if we're multiplying? You add them together. So this would give me s to the 9. Did you want to modify what it says? It's to the 2nd power. Great. So let's go through and we'll change that. So this is going to be squared. Now, as we construct this again on your paper, you give the shell of it and then we'll fill it in. So there's a binomial, a trinomial. Your signs are plus, minus, plus. And Alexa, what do you get for your binomial factor? Can you give us the trinomial? Let's ask this way. What's the left square? Close. 25t squared is correct. What do I get when I take the middle 2 terms, Cassie, and I go through and multiply them together? And what's the sign in front of them? And now to finish it, Eli, what do you get at the end? Close. It's 6s squared to start with. So take that and square it. Your 36 was right. You take s squared and square it. How many s's would you have? Perfect. To the 4. Make sure you pay attention to your signs. Now, the next thing that we're going to do, there's no GCF. Some people would argue, well, you could expand the whole thing out and then try to factor it down. It doesn't work. That's not very efficient. Take the cube root of the left, the cube root of the right. The cube root of the left would be the quantity x plus 2. The cube root of the right would be a t. Now, I'm actually going to need parentheses inside of parentheses. Since I knew that going in, I use secondary parentheses, which are brackets. You don't need to. My signs going across there needs to be space for a binomial, which is actually going to become a trinomial, and then a trinomial, which is going to become more. I need to take the left plus the right. So that's going to kind of be easy. I have a t plus 2, or sorry, an x plus 2, and then plus a t. So that's easy, and I can simplify this down easy in our next step. In order to get the next piece, it's going to be left squared plus left right, or sorry, left squared minus left right plus right squared. So I take the left and square it. And I'm just going to write it out the first time. You don't need to be a mental math hero. We can handle that over to the side. So we get to that. Now I'm going to take minus the left times the right. So minus the quantity x plus 2 times t. And then at the end of that, I need to have a plus t squared. So we get to here. Now there's more work that we can do to finish this out. There's actually two things that if you're looking at this as an enriched student, there's two things you should see. That, we can expand. This, I can not expand, but distribute. So there's two things that we're going to have to do. And by the way, at this point, what's the leading coefficient here? 1. Distribute out of 1 and put like terms together. It's not going to give you anything there. So we get that. Here's the part where, for me, it gets frustrating. You've got to be able to recognize, if I take the quantity x plus 2 and square it, you have to list it out twice. And it's okay. There's going to be a lot of times where we're going to need to do some math, and we'll head over to the side of the paper to get it done. So let's list out the quantity x plus 2 squared, which means it's times itself twice. Now, I will let you know this. I am quite prejudiced against the, the magic rectangle thing, or the box of fun, or whatever it is. I am a FOIL person, first, outer, inner, last. If you need to do your own little squares of joy, or whatever they're called, you're free to do so. But I don't. When I demonstrate it out, I just do first, outer, inner, and last. So to do that out, I take my first terms and multiply, because I'm taking this and evaluating out what this is. So I've got quantity x plus 2 squared, wrote it out. Now I'm going to do the double distribution. First terms are going to give me x squared. The outside terms are going to give me x times 2, so that's plus 2x. Inside terms are 2 times x, so that's another 2x. And at the end, I've got 2 squared, and that's 4. I can condense that down. And by the way, you actually should, and after one or two of them, you can do them right in your head. This would give me, when I combine like terms, x squared plus 4x plus 4. That's the first piece of the simplification of to get to the answer. Now, there's still more that we can do. Yeah. Now, how do you walk us through, I guess, how you're going to do the multiplication, because there's more than one way to get it done right. What would you do? You were saying distribute it out? Okay, so what would you then write out? Oh, no. The negative doesn't go to this. You're distributing, it only goes from left to right, left to right, so this would go from here out to this. So if you distributed the negative to this quantity, what would you have? And then you'd have to still multiply that by that t that's hanging on there. If you want to do that, that's fine. In my head, when I did it, I just distributed out a negative t once. I changed the order. You're going to get to the same answer. When we do that, we would have negative xt, or tx, minus 2t, and then at the end, nothing needs to be done, and that's what you'd be left with. Now, is that difficult? Sure. And again, your goal when you're in here is to get, I'm going to throw the kitchen sink at you. Should you? I want you to think of it from my perspective. What percentage of you should be getting this question right? This 4A. If I'm looking at this and you're all not getting it right, then I'm concerned. It's sort of, I like to say, the millionaire's test. If everyone can go through and do it, I really don't care about it. It's not significant. Just like if everyone was a millionaire, would it be special? No. Okay. So if everyone can do it, I don't care about it. That's fine. I give up. You're good at it. So I'm going to go and throw questions at you where there's actually going to be a noticeable amount of you are not going to get it right, or at least struggle with it. I want you to struggle. I want you to have anxiety when you're taking the test, and when you sit down for the Regents exam, I want you to almost be laughing at how easy it is. Laughing. The one thing that made me so proud was two years ago, I had a kid who started off the test. By the way, when you take the Reg, I always have you start at the last question because that's the toughest one. He went through and looked at the last question. And I looked over and he starts going like this. And he kept doing it over and over again. And then he's doing it throughout the test. And after the test, I was like, is there something wrong? Like, were you angry? Were you pissed off? Did you get a 0? What was going on? He goes, that was such a joke. I was insulted that it was wasting my time. I almost cried. I was so happy. That's what I want you to think. You know how, like, raise your hand if you've seen the movie 8 Mile. Some of you know. It's a common, but I'm getting older in the movie. It's so big. When Eminem had a battle rap the first time when he won, he dropped the mic and walked away. When you finish that exam, I'll give you permission, create a scene. You drop your pencil and walk away. That's how much I want you to own the test. I want you to sit there and be like, you get the exam back and you can say in your report, you got a 96, and go, so terrible. I should have had a 100. That's what I want you to say. That's the level that we're working with. So are you going to be doing questions where it's powder puffs like 4A all the time? No, please. You may get 1 on an assessment because I'm being very nice. Questions like C and E here, that's what we're going to do. They're to push you. I want you to be amazing. And I'm not here to build up your egos. I'm here almost to break them down so you can get past thinking you're good and you get to actually being good. All right. Now, we left off, I think that's it. If you need more practice problems, there's some here. These are difference of squares. Did I give you? Yeah. You can go through and pick from over here what you want to do. Should you be able to do this question? Yeah. It should take you like 4 seconds. This question here you should be able to do in your head. If you've done enough that you can do that, that's how many you need to do. And the problem, again, with Enriched is no one explains to you, and it's not to be derogatory in any sense of this explanation. There are some of you who are math thinkers who don't need to study, ever. You see math, you see it once, you're done. You've got it. You do one example, it's automatic. And then there's another subset of you who you don't see it, but you are a worker. And you'll do 40 of them, and then you'll be terrific. And you'll be fine. But I'm not going to sit here and tell the kids who are mathematically inclined, do 800 of you so you end up hating math. And the other end of it, I'm not going to give you no examples because some of you need to do more. You've got to figure out how much you need to do to make yourself successful. Look at question 57, 58. Those are extending ones. One like 59. It's an extension question. This, 63, a little bit of an extension. Now, let's go back over. We're going to do some easy ones and then some that are a little bit tougher. Take a look, please, go back to page 3. And these are the powder puff factories that you all did back in Algebra 1. Is there a GCF? No. Is it a sum of perfect squares or sum of perfect cubes or difference of cubes? No. It's a trinomial. So what you're going to do is we need numbers that multiply to 35 and add to 2. So in the beginning, we'll walk you through like they should have the first time. On the side, I always have you list out the factor pairs of that last value. So I've got 35 at the end. Hands up, please, if you can tell me one of the 2 possible factor pairs that I could use to get to 35. Go ahead. So I could use a 7 and a 5. Who can tell me the other one that I could go through and use? Everybody forgets this one. It's the easiest one. 35 and 1. Yeah, so we'll list out 35 and 1. Now, is there a way to arrange these factor pairs to get a 2? Well, my first candidate that I think I'm going to try are these 2 here. And the way that this factor pattern works is I need values in the beginning, and you're going to give me 2 sets of binomials. You can fill in that lead value, because the lead value is what's going to have to multiply to give you the x squared. And that's going to be an x times an x. I need to fill in the secondary part. How can I fit this, or how can I arrange it such that the outside and inside will give me a positive 2, and then the last values, when I FOIL them out, is going to give me a negative 35. You can tell me what numbers I would have to have that. We got 1, 2. What do you want to set? So let's go through, and it's going to be a positive 7 and a negative 5. Now, so you see what we're talking about. And again, on these ones, it's easy. On the ones that we do later, it's going to be hard. So if you understand this process, you'll set yourself up well. In the beginning, I have an x and an x. That's what's going to multiply to give me an x squared. Over here, I have a negative 35. These numbers here are what are going to multiply to give me the n. The arrangement of them causes me to get the middle term. The middle term is caused by the arrangement and the positioning of them. Go through right now, please, and do A and B on your own. Alex M. Which one do you want to do? Do you want to do A or B? All right, what did you get for Alex? What did you get for A?
I got for the middle number, I got 30. Negative 30.
Hang on. What would you put to start this back up?
X plus 6 and X minus 5.
Careful. What variable are we using? T. So it'll be
yeah.
T minus 6 and T plus 5. All right. Tally, what'd you go through and get for the second one?
The second one, W minus 8 or plus, W plus 8 times W plus 4.
There you go. Questions on that? Now, go through, please, and do out example 2 on your own. So looking at that, I listed out the factors of 7, which are 7 and 1. Hands up, please, if you can tell me what this is going to factor down to be. We've got 2 people, 3. What do you want to say? All right, let's try that out. You said m plus 7 and m minus 1. Now we're going to FOIL the check to see if it works. We've got m times m. That gives me m squared. My outside gives me negative 1. The inside gives me positive 7. So 7 minus 1 is going to give me the 6. And then positive 7 times negative 1 gives me the positive 7 I'm looking for at the end. Questions on that? Are they lemmings? I think it's called lemons. They're little like with a little mouse in it. Like if one of them runs off the hill, the whole herd of them runs off the hill. No one stops.
7 times negative 1.
There you go. We need a positive 7 there at the end. What do we notice about this? Yeah, you can't do that. There aren't ways to multiply to 7 and add to 6. So what's that called if it can't be broken down into its component pieces? Yeah, it's called prime, and I'll give you a hint. Some of you see, and this is another thing, you go when you don't really look. Now, and it's fine because the one thing that I find hilarious, there was a couple of years ago, I went over to Spry and I started talking with some of the teachers and I was like, when you do factoring, show me what you do. And they were so proud. This lady comes over, she's like, oh, I have this, and she hands me this sheet and it's like 14 pages long and it is like the same factoring type. It was literally like called 500 factoring questions. And it was so much, and it was the same thing, and I'm looking at it, and it was smaller font for this, and I'm like getting dizzy looking at it. So I go home, and I'm trying to do them, and I got through like 80 of them before I'm realizing that it was like offensive to me that you think that I'm, this dumb that I have to do all of these questions where it's the same number 100 different times over and over again. Go away. The same number over and over and over again. And I looked at it and I brought it back and I go, so you gave me the sheet. How many of these don't factor? None of them. They all factor. That's the whole point. I'm like, does every quadratic that you encounter in life factor? No. So why would you train children to think that if I put it in front of you, that it's going to factor? Like, you have to have a little bit of a, and that's the difference with some of you, and it's not to be disparaging in any way, but if you have a math mind, you would look at that and say, wait a minute, I can't get that. But those of you who are really, really hard, diligent workers, who, by the way, they tend to get very, very far in life, people who are math geniuses sometimes end up being, cleaning toilets for a living, because they never do anything with how smart they are. But you sit there and you go, if you're a rote thinker, you would automatically assume, since I gave it to you, it has to factor. Like, you wouldn't ever question me ever. I'll make mistakes constantly and wait for you all to catch them. That's the whole point. I want you to be a real analyze everything. And you all, by the way, will see it during class. You are merciless. If I'll forget a negative sign throughout it. You give me visual daggers. You look at me, you judge, and you go, that's wrong. No, it's plus this. And you yell it out. And that's fine. Be that person. At least it lets me know your brain is working. Now, looking at the next one. This one does factor down because it doesn't say prime at the top. You're factoring with two variables, so I'm going to leave two sets of parentheses, and I'm going to go back to that pattern that I mentioned before. You all probably don't have a highlighter on you, but I do. I'm going to say, these first values have to multiply to give me the x squared, and I'm going to fill something in. I need to fill something in here and here that's going to give me the negative 16a squared. Now you're limited. The arrangement of them and the choices I make are going to cause me to get this 6a. What do I need to have in the yellow positions? Hands up, please, because this, you're going to be ecstatic when you see x squared. It's so basic, it's not even funny. What? You're going to fill an x in for both of those. Now, at the end, I've got some choices to make, because negative 16a squared, there's two different ways I can get it. Well, there's, I guess, 1,000 different ways, but using integer coefficients. Hands up, please, you can tell me one way that one candidate for those green positions. Give me one. Careful. You're missing one thing when you told me that. 8 what?
X.
Nope.
Oh, A.
A. And then we also have a 2a. So that's one choice. Who can tell me the other ones that I need to remember? Yeah. Good. So I'm going to need to make sure. Now I've got candidates. And you check, and sometimes it works, and sometimes it doesn't. So, and by the way, it needs to be, is that negative 16? Is that right? Okay. So I need to have one be a plus and one be a minus. It's not really going to matter, so I can leave that there. So I'm going to take these candidates and say, all right, if I plug a 4a in here and a 4a in here, is that going to work? Yes or no? Hands up, please, when you can tell me what this factorization should be. Play it out in your head. Write it out. Try the FOIL, and let's see what we get. Go ahead. Let's see. Plus 8a, and then minus 2a, and we'll check to see if this works. X times x gives me x squared. Outside gives me negative 2ax. Inside gives me positive 8ax. So that gives me the positive 6 that I was looking for in the end work. So can we do that? Let's hope so. How about, for example, 4? Hands up, please, if you can tell me what you'd want to do to start off example 4. I got 1. 2 of you who see?
GCR.
Of?
16.
Close.
16Y.
16y. What's left? Hands up, please, if you can tell me what's left after I factor out the 16y from all three of the terms in that trinomial. I've got 1 so far. 2.
Let's go and do it.
John Paul.
Y squared minus 2y minus 3.
Are you done? When you have this on your paper, are you going to call it a day now? Look at that trinomial. Can you go forth? Can you go further with it? Absolutely. Absolutely. Hands up, please, when you can tell me the complete factorization of this. We've got 1, 2, 3, 4, 5. What do you want to say?
Y minus 3.
And? What's the one thing you didn't tell me that needs to be there too?
16.
The 16y. Don't forget about that. Now, the last ones that we're going to look at, you're going to hate doing examples. You would wish that this number was a 13. You would wish it was a 7. You would wish it was a 91. 12 is a terrible number to have in front. Why is 12 a bad number? Why would you want 7? Why would you want 91? Why would you want 101, but not 12? Those are prime. This is composite, which means it's got a bunch of factors. So I'm going to break this down, and I know there's 2 sets of parentheses here. One of them in this yellow spot, I need to have numbers that are going to multiply to give me 12r squared. And then over here, in this second spot here, which I'll have in green, that's got to multiply to give me -2. The problem is with that 12r. So I've got all of these candidates to go through and pick from. So one of them would be a 12r. Oh, I don't want that. Let's pick this one. So one of them is going to be a 12r, and that can get paired with an r. The other ones that I go through and have would be, or candidates for that yellow spot are 3r and 4r. I also need to take into account 2r and 6r. Oh. We need to have a plus sign and a minus sign. And factors of 2, we're lucky there that the n number is prime, so I guess the difficulty of the yellow is made up by the easiness of the green. So we've got all of these candidates to go through and choose from. You are literally going to make a guess and check and see if it works. That's why you do math in pencil, because it's going to be a lot easier to wipe out the bad guesses. Now, let's just say I start off with this. By the way to check to see if something factors, this is the trick, to see if this factors or whether or not you're going to write prime, isn't to read this. You actually have to do that. 12 times 2 gives you how much? 24. Are there numbers that multiply to 24 or negative 24 and add to 5? What are they? 8 and 3. So can it be done? Yes. It's not saying you use an 8 and a 3. It's saying is it possible. So let's try this. I'm going to start off with a 6r here and a 2r here. I'm literally taking guesses. And then maybe a plus here and a minus here. And then I'll do, I don't know, a 2 here and a 1 here. Now, I took a guess, and I'm going to check to see if it works. So my first terms, does that give me 12r squared? Yes. The outside terms are going to give me 6r, and then negative 6r. And the inside terms give me, so negative 6r plus 4r would leave me with how much? Negative 2r. What am I looking to have? Negative 5. So did that work? So guess what we're going to need to do? Try again. Now I'm going to tell you this. Before you erase it, this would not be something I would ever even try as a guess. What does this answer have that the original does not? Does anyone see what the answer has that the original does not? Remember. No one sees what this has? Technically it's this. That this doesn't have? Nope. Bigger than that, because remember the arrangements that we got to get a -2 somehow. What does this have? The GCF. How can the GCF have an answer if the original doesn't? So I'm never going to pick and try a pair that doesn't. Does anybody know what this would? So by the way, that eliminates 6 and 2r as candidates. I think it's 3r and 4r. Let's try this. Wait a minute. Switch the signs. Okay, so let's try this and this. So doing this out, this gives me 12r squared. Outside is positive 3, inside negative 8, that gives me the negative 5. You would try, so there's a ton of guesses, but if you're cognizant of what's going on, you're not randomly guessing, you're making very, very educated guesses. You went from having like 24 possibilities down to 12 possibilities down to, I think, 4 possibilities. So that's a lot that you can eliminate. Now, in the other classes, if you go and watch and want to see example 6 done out, the other classes we were able to finish it. I would bounce over and take a look. There's more practice questions that you can do. I'd say 1 through 4 in reality. If I'm looking at these questions before you go, do as many as you need to be ready for the assessment coming in next time. Their time, you're going to have to make sure you know your stuff and get through them successfully. I think I have a grade, if next time I have at least one assessment, 2 of them that should come back to you. Raise your hand if you're able to log into the portal. Make sure you get that resolved this weekend. Who's able to set up their Math Excel? Fabulous. If you haven't, make sure you get it done by this weekend. You'll have an assignment in there to finish by Wednesday of next week. It's just the orientation, but that'll be assigned to you this weekend. Have a great weekend. What's that? If you go into Google Classroom, there's a picture on there to click on that gives you the instructions. It's got the access code and your class code. Okay? When it says access code, it's one the longer of the two. Okay?
I never get anybody my stuff.
Yeah, I don't know algebra.
Oh, good. Then Algebra 2 is going to be definitely a little tough for you.
Like, I'm gonna need a lot of help.
Okay.
Because I almost failed any. Well, like, I passed, but like, all the time I shut down. What blocks are, come in here, what's you?
Or if I'm just enjoying math, but you need help. My schedule, I've only put about 6 places. So there's one here, there's one here. Okay, but no, I'm not a spoon feeder, so make sure you got actual questions. Give me a
I have
heads
actual questions from class.
up. Okay. Go check in with your study. Oh, wait a minute, I think I have study hung up too. Hang
I have a
on.
great question.